We are located in the Antea area, the northern part of Querétaro City, and we are going to be looking at the youngest stratigraphic section of the Querétaro Graben. This is a quaternary Pleistocene to Pliocene stratigraphic section. Just to give you the Boulevard of the La Nación is a road that is located in the mountain hills of Querétaro, right to the east of the area where we are right now. And the sedimentary successions that we are going to see should be on top of the Boulevard of the Nation Hill. That is a good evidence of how a graben is forming due to the fact that normal faults had been acting in this area and opened the Querétaro Valley. Now we are going to take a look on the stratigraphic section. Here in Antea we are in a quarry where a lot of this material is being mined for construction purposes. Usually this is a material that is made out of silicate minerals that are being used for as aggregates for the cement during the concrete constructions. Now we are going down towards the outcrop, and in here what you are going to see is a series of laminated strata that are made out of siliciclastic material, mostly quartz, fragments of volcanic and intrusive rocks that had been eroded from previously outcropped materials here in Querétaro. So most likely the materials that are located in the Cañada and the materials that are located at the Congress Center, these materials are going to be were actually eroded and redeposited in these deposits, right? You see here that the laminations are very tabular, and also the strata are tabular as well. They are very horizontal, parallel to each other. However, there are areas, and you're going to see in this area here, we are going towards that direction. Just a moment. You're going to see that there are some areas in which you can actually see some channels, right? We are getting there. You see this channel here. You see that it is like a smile, right? Usually the strata are tabulars, but now you are looking at this very beautiful channel that is made out of this reddish material. The red material is how you can distinguish that smile kind of shape. On top of that, you are going to see that again you have the tabular materials. Usually there are some materials that are black and white. This can be showing some kind of different processes. It can be a process of changes in the original material that was eroded, or eventually changes in the biological material that is affecting and altering this material. This is what we call biological weathering, right? Also, you can see that in some areas the tabular material inside the strata, you have also small variations in the laminations as well, and those materials are showing you that the different source of materials were changing through time. That can be climate related or source area related. Climate related, remember when we talk about continental weathering, usually the materials that are more rich on ferromagnesian materials are materials that were eroded during periods of cold climate, and the materials that are more enriched in silicates and felsic materials are materials that eventually were more predominant during periods of high temperatures. However, it can be also that the materials could be full of feldspar, and remember that the feldspar is a very easily weathered material, so therefore you have to make a thin section, and we are going to look at that in some examples that I'm going to show you in the screen during class. Some materials that are more full on feldspar is very difficult to actually determine the weather conditions that act during the period of deposition of these materials. Other than that, this is a very classical example of an alluvial plain with rivers that were running along the area of Querétaro right after the opening of the graben due to this tectonic activity associated to the Trans-Mexican volcanic belt. After this outcrop, we are going to go to the Boulevard de la Nación, which is the part of the Querétaro stratigraphy that should be below this material, but that is actually right on top because of the fact that we have these normal faults acting in the graben. Okay, that is everything for this outcrop. Let's go to the Boulevard de la Nación. Okay guys, so we are now located at the Boulevard of the Nation, Boulevard de la Nación outcrop. This is a very interesting outcrop, especially because it shows two intervals of geological events that happen here in Querétaro. The first event is the deposition of sedimentary successions that are intercalated with lava flows. And the second one is the origin of the Querétaro graben, which, as we had already mentioned, is the result of a series of normal faults, so extensional movements that gave birth to the Querétaro area, the area where the city is located, the area where the Antea outcrop is located. As you can see here, you are going to have a series of laminated strata. So you have some tabular strata that are changing in the composition in this special outcrop. You actually can see the changes in the composition of the sediments that gave origin to these sedimentary successions. You see changes from a dark material, which is most likely associated to the erosion of the rhyolitic rocks that were originated from the volcanic activity in this area, and the white ones, or the light sediments, are eventually the result of some tough eruptions here, so eventually some volcanic eruptions that put these sediments on top of the rhyolitic material that had been eroded. Towards the area event that happened here, as we had mentioned before, is the Querétaro graben formation, and in this video you are going to see the one of the normal faults that occur in this outcrop. Basically, you see that several of the tabular strata have no continuity from the right hand of the block towards the left hand of the block, and remember that this is being cut by the normal fault. And usually the normal fault, as we had mentioned in the class, is having the block that is on top of the fault going down, and the block that is on top of the fault, below the fault, is remaining in the uppermost part. So there is a discontinuity in the horizontal variation of the strata. Footage of the outcrop, what you're going to see is a big movement of of one of the strata. You see on top of the outcrop several yellowish, white, and brown strata. The strata had been moved by several meters. I will say that in this area the vertical movement of the normal fault could be at least 3 or 4 meters in between the strata. And then if we go towards the left, you see that over there, you see that the strata, the brown strata, are not anymore over there, and now it is replaced by some reddish, brownish strata, but not as potent as the previous brown strata that we were looking at. And on top of it, you see that we have some basaltic rhyolitic materials. So these are basically lava flows that were deposited on top of the sedimentary succession. And there is no continuity of this material towards the right part of the fault. That is something that is telling us that eventually the movement is even more drastic in this area, where there is not actual continuation of this volcanic material. You see there that the strata are being folded, and that is what we call a growing fault, and that is showing you that the basaltic rocks were on top of the sedimentary rocks that are in the right part of the succession. This is a very interesting outcrop showing us these tectonic features. Now we are going to show you some sedimentary features as well. We are going to go towards this area here. And we are going to go to the very lower part of the outcrop. A little bit lower, we're going lower here. You see here that some of the strata are having some continuity, but others, like this one here, they are not having any continuity. So you have some like kind of sedimentary structures that are showing you that there are differences in the sedimentary regimes, while sediments that are more tabular are more all right. Is that you are going to have some laminations, like in this area here, and then there are other parts in which you have a discontinuity in the laminations. This is telling you right in the middle of the screen that the sedimentary regime had changed. This is most likely associated to hydraulic regime that has less energy than the ones that gave birth to the laminar and parallel strata. So this is something that is a very good example of how an area where you're going to be having a river acting, the sedimentary regime is happening, is changing all the time. Okay, guys, so here we are located at the Convention Center of Querétaro main entrance road. This is an outcrop of the uppermost lava flows that we have here in Querétaro. In this part of the outcrop, you are going to see that we have a series of highly chaotic blocks of materials associated to these lava flows, mostly basaltic and rhyolitic lava flows. It's a mixture of the two materials associated to a potential eruption of one of the volcanoes. I don't know if it could be the Cimatario or any other volcano that was nearby here. You see that the blocks are of some half a meter of diameter to all the way to 1 meter of diameter. So it's a very big uh, chunk of blocks that were transported by these lava flows as well. So what you originally have are these blocks being transported, and later on the rest of the massive and highly chaotic matrix was crystallized, embedding all these blocks into the matrix. We are going to go up a little bit more to see how these lava flows, which is considered the uppermost lava flow system in the Querétaro Graben, are going to be intercalated with some sedimentary successions. So we are starting going up. In here you still have your lava flows. These lava flows, guys, are similar to the uppermost lava flow that we saw at the Boulevard de la Nación. So in this area, these blocks had not been affected by any part of the graben. Most likely, towards that direction, these blocks should have been go down, but again, this is the same blocks that we found in the graben at the Boulevard de la Nación. Again, this continues through here, and here you see a second layer of some volcanic ash that has been deposited on top of the lava flows. This material is composed of pumitic material, more fine-grained material. It can be finely laminated, or it can be in some places also massive. You see that at least there were 2 events of volcanic ash falls coming up here. One that is in the lower part that is a little bit lighter, and the top one that is a little bit more darker, right? In this area, you have to be careful with the cars and everything if you want to come and visit later on, because it can be highly dangerous. Okay, in this area here is very interesting. You see that the lava flow that we saw over there are going to be changing towards something that is more like a debris flow. And in here you see that the material is more angular, that the blocks are becoming smaller, that the matrix is at some points allowing the blocks to get in contact with each other, meaning that the amount of water was lower. In other parts, you can see, for instance, in this area here, that the matrix is higher than, or more abundant than the blocks, and therefore this is an indication that a little bit more of water or a little more of more plastic conditions were acting. Importantly to mention here, that is completely different to a sedimentary succession that is controlled by rivers or by currents with associated to the ocean or to river waters, is the fact that these guys are more angular. You see that the angularity of the clasts is very high. They are very angular to angular. You have seen this in the classification of rocks, and this is an indication that this material is coming from a source that is very nearby. Remember that whenever you have more rounded material, it is because of the fact that the source area of the sediments is a little bit more farther than whenever you have these angular materials. So proximity, angular. If you have a long transport of material, you're going to have it more rounded. Okay, of course, this is not always the case. For instance, you see here that there are some materials that can be some rounder at subangular, but still the majority of the materials are more rounded. And this again is the section where with the ash flows start happening. This uh, volcanic material is fine grain, most likely varying in between sand grain into mud grain. And on top of this, again, we have a repetition of these lava flows with some variations towards the breccias. Again, this is a mixture of the complex volcanic activity that was happening here, in which two major very devastating events were separated by an event that was not that strong. Okay, if you can put this into a context of the built environment, so you can eventually think on this area located towards the most proximal part of the volcano, and this area located towards the most uh, uh, farther part of the basin. So meaning that the volcano that eventually had this material being produced, it was located farther than the material that the volcano that was producing this material here. Let's go up a little bit more, and then we can continue. You see here how this area is showing in a little bit more closer section the material of these ash falls. So very interesting. And on top of this, we have another uh, part of the section in which we have of the succession in which we have the basaltic lava flows only. So basaltic lava flow, something that is in between lava flows and material that is being reworked of a lava flow with these blocks, ash falls, and here again the breccia showing conditions of sedimentary transport of the previously formed basalts. This is a typical succession here in Querétaro, and again you can follow this stratigraphy through the whole basin. Remember that we are here higher than at the Boulevard of the Nation, and therefore this material is younger than the material that we saw at the Boulevard de la Nación. And remember that the Antea material should be deposited after this part of the graben has been already transported down by the faults, and therefore the material that we saw in Antea should be stratigraphically above the lava flow that we see, the basaltic lava flow that we see on the top. All right, guys. Hope you enjoyed this outcrop, and we are going to look at this more in detail at the classroom.